Well, hello. Welcome to the last session of the week. How to help IBM and you in capital letters quickly resolve IMS problems. I'm going to put an S on there. Okay, I'm Steve Nathan. I'm from IBM. I've been with IMS for 52 years and hope to get another 52. We'll see. So this is the agenda. We'll talk about things you can do before the problem occurs, things to do while it's happening, after the problem, how you can resolve it, and then after the problem, if you need our help, how to do that. And I stuck an appendix on there about the IMS Connect recorder trace because I get questions on it every week. And maybe this is one more place where people can find the answers. So we all know IMS is perfect, okay? But on the rare occasion when the problem, okay, it must be resolved quickly. And I'm going to show you how to make that happen. I want to acknowledge, first of all, Jeff Maddox. You old-time IMS people know he's done a presentation making it difficult for IMS problems to hide. He had several versions of that over the years. And Kevin Stewart, as many of you know, and he explained lock time and timeout and deadlock, which is very important. So this is just basically a repeat of what I said. We're going to set up the environment. We're going to do things while the problem is occurring, then try and resolve it yourself. And if not, make it easy for us to help you. Okay, so before the problem occurs, number one, this is IMS, you must have the proper tools. You should have and be very familiar with one from each set here. Okay, we need an IMS monitor. It could be BMC main view, could be OmegaMon for IMS, could be TMon for IMS, but you need something that tell you what's going on. You need something to analyze CPU and weights. You can use Strobe for BMC, or you can use Application Performance Analyzer, APA, from IBM, but you need one of those two. You need something to analyze the IMS logs and traces. Okay. There's the BMC AMA log analyzer for IMS, and IBM has IMS Performance Analyzer and IMS Problem Investigator, IMS PA and IMS PI. If you're using IMS Connect, you should have one of these two products, either Energizer from BMC or IMS Connect extensions from IBM. These are just basic things you must have. Okay. There are a number of items you can set up in ZOS, yell at your ZOS system programmers, that'll help us capture important data, and it'll also help us avoid admins. And I'll go through those. The first one is the ZOS system trace table. ZOS is constantly tracing every event that goes on. And there's an in-core trace table to do that. The default size is 1 meg per CPU, and we highly, highly, highly recommend 3 meg. So there's a command XX parmide member, and that's where you set this system trace table size, and you can display it and see what it is. Okay. If you want to have some fun, practice reading a systrace from an SCC dump. Here's the command, IP systrace time local, and I put in here a couple links that'll help you to analyze system traces. And here's what one looks like. Okay. The PR is the CPU. It's got the ASID. The work unit is basically the TCB. And then you've got exactly what happened. a dispatch or an SVC or a start subchannel, all sorts of things. You have PSWs in there. You can see exactly what's going on. And you can narrow it down to one address space if you want. Play with it. There's also a master trace table. And what that is, that's basically your MVS syslog in core. Okay? The default is 24K, and we recommend 1000K. So in the SCEDXX Parmline member, you want to put in the MT size 1000K. So if we get an SVC dump, even if you haven't sent us a syslog, we can look at it. That's very important. Okay. There's something called the common storage tracker where we keep track of every allocation of CSA and SQA. Okay. That's in the Diag Parmline member. There's this VSM track, and you must put this on for us to debug anything having to do with common storage. Okay. Then when you get an SVC dump using IPCS, you can display common storage. You can say, I want the owners of common storage, I want a summary, or I want a detail, and I can sort it by many, many different ways. Okay, and you notice it says detail all. You could say detail AC, which just means what is currently allocated, or you can say detail OG, which stands for owner gone. If you've got a program that means something in CSA and it goes away without freeing it, that CSA is orphaned and it's marked as owner gone. And eventually you can fragment or fill up your common storage. So looking at all this owner gone storage is very important. Okay, this is what the OwnCon summary looks like. It shows you all the different areas and how much is allocated in each. And then also for the OwnCon summary, it'll show you each address space and how much common storage they have allocated. So when somebody yells at you, as the system programmer normally does, and says, IMS is using all my CSA, you can prove them otherwise. And if you do OwnCon detail, what you'll get is every single piece of allocated common storage. Okay. In this case, these are things at the IMS control region. Okay. It's got the address, it's got the length, it's got the return address of the person that did the get main, and the date and time that it was allocated. And then it shows the first few bytes of what was allocated. So we can get a really good detailed look at common storage. Okay. There is another parameter in the diag called best fit CSA. What happened was they used to have best fit CSA, and then they changed it to, the first thing I find that it fits in, I'm going to put it in, instead of looking for a nice slot that it's the right size. And then everybody ran out of CSA. So they put in this parameter, best fit CSA, but unfortunately the default is no, and you must make it yes. And there are other parameters in the diag to look at. Okay, and you can display the diag. Okay, when we take an SVC dump, there's got to be enough space. Okay, the default is 500 meg. Okay, you want 5,000 meg. So when the COMMNDXX Parmline member, okay, please specify the max space. And you can do a display dump options and see what's in there. Okay. SVC dumps. Obtaining SVC dumps is very important. You can take a manually dump, or you can set a slip to create a dump. And these commands and slips can be prepared ahead of time. So when you need to issue one, it's much easier instead of having to type the whole thing in at the system console. There is a ParmLive member where you can put in dump commands, and then there are ParmLive members where you can put in slip commands. And you can have wildcards in there even. So let's look at this. If I want to just take a manually dump, this is the hard way. I go to the ZOS console and I say dump com equals, and I stick in some comments. It comes back with an outstanding reply, and then I have to type in everything you see below. Reply, job name, there are other parameters you might want. Okay. And you have to type that in every time. But if I had this in the IEA CMD, we'll call it maybe IM, ParmLive member, if I put this in there, it's basically I've typed it off ahead of time, and then I can say dump com equals comments ParmLive equals, and I give it the suffix, and I've taken the SVC dump. So you can prepare things ahead of time. Very important. Slips. Okay. We're constantly telling you to set a slip to catch this event or this message or whatever. Okay. And there's a lot of typing. But you could also put a lot of these slips into ParmLive member, IEA SLP XX, and then just edit it a tiny bit if we ask for it, and then say set slip equals XX, the suffix, and it'll happen right away. Okay. Here are some skeleton slips that you should have as IEA SLP, maybe AB or UA for user addband or MS for message addband. And then you just have to update a couple of parameters in here and then set the slip and give it the suffix. Okay. SMF records. These are very important. And what I've listed here are what we consider the minimum number and the minimum types of SMF records that we need you to collect for us to do our job. So now SMF 7915, a lot of people didn't capture that. If you're doing IRLM and you're doing deadlocks and timeouts, you must have those. SMF 98s are new, and that's a very detailed ZOS performance statistics. Okay. None of these are going to kill you in terms of performance. Okay. If IMS control region fills up and it tries to take a dump at 878 or 80 able, and when that event happens, ZOS needs storage to create the dump. So if the dump is taken successfully, the IMS resource cleanup module, DFS MRCL0, Mr. Clean, will get called and will clean up IMS storage. There won't be any owner gone in CSA, for example. Okay. But if there's not enough storage, when you try and take a dump, you might get an ABN 40 dog. This is bad. Called terminated end of memory. You don't get all the data in the dump, and the IMS resource cleanup may not be called, and it's a mess. But you can reserve storage so that in an address space, so that if it has to take a dump, it's got enough. You can code this SMF exit, IEFUSI, and there's a new way now. There's an SMF LIM PROCLI member, and in there you can say I want to reserve 50 meg above and 512K below in case there's an event. And we very, very, very strongly recommend this.
That's it. That's a good one, that, because we've just had a few of those S40Ds, and we're getting them to give us a slip. But actually, we better look at the SMF lim Palm Proclim
That's
I'm assuming
fairly
that
new,
that's,
and
yeah,
yeah, you don't have to
thanks.
yeah, coding the IFUSIX, it's no fun.
Okay, yeah,
You know,
we'll look at that. Thank you.
yeah. Okay. So also, if you set a slip before he does the 80A and the 878, you might get a better dump. So I recommend that you have these slips set up in the IASLP. So if you get an 80A or an 878, we'll get a slip dump first before he gets anything else. And we might capture some information. Okay, what if you get a 322 or a 522? Well, if you happen to be in the middle of an IMS call, you can bring down your control region on a 113. Okay, if that's your NPR if it's looping, or if it's an 08 too long. Now, there's a JES exit, IEFUTL, which if you get a 322 or 522, it'll catch it and it won't abend and you'll keep your IMS up. And IMS delivers in the sample live a DFS UTL, which is a sample exit you can use to code your JES exit. And fairly new, you could also get an event 722 on exceeded lines. I've seen that. So there's another JES exit, IEF USO, and we deliver a DFS USO. Okay. In the IMS control region PARM, you must specify FMTO equals D so that if there is an abend, we do get a nice SDC dump. Okay. And if the S dump fails, okay, we're also going to have a sysm dump DD card in all the IMS regions. So it'll try to take an S dump or it'll take a sysm dump. And there's a whole big write-up on the dump options in the IMS manuals. So here's the sysm dump. Specify disp equals mod. Okay, there's this IEA DMR00 is where you specify the S data for the sysm dump. And then here's an example of the DD card going to a GDG, which we highly recommend. And of course, your dependent regions, they're going to get sysu dumps. And the IEA DMP my member is where you can specify the S data for those. The IMS dump formatter. IMS has a formatter which you can use when you're looking at an SPC dump that has IMS in it. It's an incredibly extensive IMS dump formatter. Okay, I put in the link here on how to install it, and you should install it and you should play with it. Okay. There are some IMS internal table traces which should be on at all times. Whether or not you've had a problem, whether or not you're expecting a problem, you never know when you're going to get the problem. These are internal traces. They just loop through trace tables. So I'm not going to fill up any data sets anywhere. In the DFS VSM ProcLive member, okay, we specify, you should specify these 4 traces as always being on. And then if we get a problem, we can go look at these traces. I've done that many times. Okay. We may ask you to make them external, and then you'd set this command and then you'd say option log. And there are a lot of other table traces we may ask you to turn on, but the 4 listed above should always be on, just in case. Okay. There are external data sets. There's DFS TRA01 and DFS TRA02 DD cards. Okay, you can put in DD cards, or most customers just use the dynamic allocation members in DFS NDA. If these are not present, then if you say option log, the traces are going to go out to the olds, and that could affect performance. If you say option log and these data sets exist, then they're going to go to these trace data sets. Okay, one of my favorite topics. Lock time and deadlock. These are very, very important parameters if you're using the IRLM or IMS database locking. Lock time is an IMS parameter, and we use this to tell the IRLM how long to wait for a lock before it times out. Now, you don't want to wait forever on a lock. And you can specify it in the DFS VSM PROC member for the online system or the DFS VSANP for batch. Now, the lock time corresponds to an IRLM parameter called timeout, which basically that's the parameter IRLM uses to time things out. There's also a deadlock parameter. That's an IRLM parameter, and it tells IRLM how often to look for deadlocks. If you're using IMS-PI, if you're not using the IRLM, that's just IMS locking. IMS is smart, and it catches deadlocks as they happen. But for IRLM, he only looks for deadlocks. He wakes up, goes through, looks at all his locks and says, do I have a deadlock? And if not, he goes back to sleep. So you have to specify how often he wakes up, what's the interval that he uses to look for deadlocks. Very, very important. So here's this DFS VSM PROC member. You can specify a time for the online systems, and you can specify a time for batch and VMP and JBPs. You can specify from 1 to 32,700 seconds if you want to wait forever. And then you could say, if the lock times out, what do I do? Do I event on a user 3033? Or do I just give a status back to the program? You have to decide. And there's a very long write-up in the IMS manuals, and I've given you a link to that. Okay. Now, IMS always passes a timeout value to IRLM to tell them how long to wait for locks. If you don't code the lock time, then IMS is going to pass 300 seconds, and you can wait 5 minutes for a lock in IRLM. But if lock time is coded, we're going to pass the smallest of the online or batch values. If the timeout is exceeded, what IRLM does is call our timeout exit. Okay. IMS checks to see if it's online or batch, so he knows how long he's supposed to wait. And then may tell IRLM to reject the lock. IRLM is going to issue the message. IMS will write an SMS 7915 record, and then you'll either get an addend or a status code depending on what you coded. Okay, I can change the IRLM timeout value with a modify command. I can change the lock time parameter in IMS with an update command, but that doesn't change the timeout value in IRLM. You have to change both. Deadlock is never passed by IMS. It's only established in IRLM. And IRLM only looks for timed out locks during deadlock cycles. So at every deadlock cycle, IRLM will wake up, look for deadlocks, and look for long locks. What should this be? We recommend a deadlock time of 1 second. It should never be more than 1 second for production systems. IRLM only checks for a deadlock after 2 cycles. So if you set deadlock equals 1, you can wait as long as 2 seconds looking for a deadlock or a timeout. And then the IRLM timeout value should be an integer factor of or equal to the lower of the online or batch timeout value. Very tricky, isn't it? Yeah. What I have here in red is brand new. Only happened within the last few weeks. Some of you may even recognize this. I'm not going to mention names. Bank in England. Okay. There have been occasions of IRLM not detecting deadlocks. And there's a brand new IRLM APAR, which it now has a PTF on it. And now there's a brand new IMS APAR to take advantage of the IRLM APAR. It's still open, but follow it, BH65858. But pay attention to those, please. Okay, let's go up to the common service layer. Okay, boy, I'm running out of time. These are the common service layer address spaces. I've got them listed here. And these are all built on a set of services called BPE, Base Primitive Environment. It provides tracing and it provides a whole lot of other things. And if there's an abend or if there's something wrong, these trace tables can be very helpful for us. And these trace tables are defined in a BPE CFG XX proclive member. Okay. And what I've listed below is what you should put in every one of these CSL address spaces in the BPE CFG proclive member. Okay. You can use this exact same one because if you put a HWS one into an ODM address space, it's just going to be ignored. So please just code up this one and have it for every CSL address space. It takes up a little bit of storage. I've recommended this to hundreds of customers. I've never had a performance problem with it. Okay. If you're not familiar with DFS ERA 10, okay, you should get. Okay, this is the file select and formatting print utility. It can play with IMS log records. If you're trying to find IMS log records, this can be very, very helpful. You can select all records based on a string. You can select all records based on bit settings. You can select records based on data fields. You can print records or you can copy records. And you can use this on any file, not just IMS logs. I've used this on image copies. Any file ERA 10 could look at. Doesn't know what an IMS log is. Okay, and it's got start after, and stop after, so you can just look at a selected part of the log or copy a percent or just a part of the log. There is a stop af parameter and always code stop af equals EOF. Because if your file is greater than 16 meg regs, the default is it'll stop after 16 meg regs. There's a DFS ERA 70 exit routine where you can select all records, well, based on any one of these fields. It knows a PST number. It's very, very smart. So look at these. Also, the DLT0 test program, DFS DDLT0, and you can use that to issue IMS calls based on sysint control cards. Okay, I'm not going to go over the things here, but you've got a link there, and this is very, very handy. And you can also dump DL1 control blocks and buffer pools. Okay. You can send a message to the system console, and so if you want to start program A and do WTOR and hold it, and then run B while A is waiting, and then B released, A released again, you can do that with DLT0. Okay. Run the IMS DC monitor on a regular basis. Okay, the IMS log is for restart and for recovery. It's not for performance. You can use it for some performance, but it doesn't have nearly what the DC monitor has. You should run it, first of all, once a week at the same time, even just for 1 minute, and then run DC monitor reports. IBM supplies DFS UTR-20 to produce reports on the monitor, and they're not very useful. You've got to use either the BMC or the IBM utilities. Something very important, monitoring the IMS variable pools. These can cause performance problems and you don't even know it. I've listed here all the pools. You can do it one command. This pool, then you give it all these names. This is what will come out. And what you see is the current size, what's currently free, and what the high water mark was. In this case, the CSA PSB pool filled up, which means if you try and start another region or if you try and schedule something in a region, you might get a pool space failure. You should issue this command on a regular basis. And on this next slide, I tell you what all these pools are, where they're located, and in some cases they have alternate names. For example, the DMB pool is also called the DLDB pool, things like that. So study this foil, please. Okay. Avoid OTMA floods. I already told you how to do that earlier in the week. Be up to date on maintenance. Okay. These are just a few of the important things that have come out quite recently. Okay. So just an example, definitely keep up to date on maintenance. Okay. While the problem is happening, have the documented procedure for gathering my documentation. Don't wait for us to tell you what to do. Set up automation. Okay. If you're having a performance problem, the first thing you should do is turn on the IMS DC monitor. Okay. I know you're saying, oh, I've got a performance problem. Turning on the monitor is going to make it worse. It's not. It's not that much overhead, but it's going to get extremely valuable information. If you can run it for 2 minutes, I would be thrilled. If you can run it for 60 seconds, that's enough. I'll even settle for 30 seconds, but run the monitor, please. And you can start it and tell it to turn itself off automatically after n seconds. Very important. Okay. Look at online monitors. Do you have a Megamon for IMS? Do you have MainView? Do you have Tmon? What do they say? And in red, because I tell this to every customer every time, look at RMF Monitor 3 or the equivalent. Are there CPU delays? Are there DASD delays? Are there NQ delays? Okay. Over 50% of the performance problems in IMS are not IMS. There's something affecting IMS, and RMF Monitor 3 can find it. If you've got a problem, go look, please. Okay. Set a slip. Okay. If you're seeing a constant error message, set a slip on the error message. If you're seeing constant user appends, set a slip on the user append and get it done. Don't wait for us to tell you to do that. Take an SVC dump. If there's something wrong, okay, I showed you how to take a manual dump. Make sure you include the control region, the DL1 region, DBRC, IRLM. Include any suspect dependent regions. Include anything else that's important, kicks, DB2, MQ, whatever. And all the regions should be in one SVC dump. Don't take a dump for each region. Okay. If there's a problem with OTMA, there are 2 traces I'd like you to set on. Trace set on team member XXXXX and then trace it on table OT option log volume high. That's an internal trace table. And then take an SVC dump of IMS and include IMS connect or NQ in the dump if necessary. Okay. If there's an application problem and he doesn't like what's happening with his database calls, turn on this trace. Trace it on PSB, give it a PSB name and the keyword comp. I'll tell you what to do with it later. If there's an application problem with IMS DC calls, change, insert, purge, etc. to IO PCB or all PCB. You want to say trace set on program and give it a PSB name. These are things you can do while the problem is happening. If you've got a CPU problem or a wait problem, turn on APA, turn on strobe. Don't wait for us to tell you. Okay. If there's a problem in IMS Connect, turn on the recorder trace. Okay. And I've detailed that in the appendix. Okay. IMS Connect extensions has collection level and trace level. Make sure you set the collection level to 4 and the trace level to 2. And by the way, just setting the trace level to 2 doesn't turn on the trace. You also have to turn it on in addition to setting the level. I'm sure BMC Energizer has a very similar function. You may have to turn on a TCP/IP packet trace. Okay. That's very important. Just trace the port that IMS Connect is listening on. LE abends. If you're getting abend 40XX, that's language environment trapping the real abend, the good abend, like OC1 or OC4 or OC7. Okay. Number one, you should set these LE options so you get a better dump. And you should also set a slip, okay, on the OCX, and that way I'll get a dump before LE messes me up. Okay. And then there's some links here. Okay. If you have to stop the IMS region, always take the SVC dump before you stop it or before you cancel it. And don't use the FIMS, whatever it is, common dump command. You're going to get a user advent 20, but it cleans up things on the way down, and I don't get a full dump. Stopping dependent regions, you can stop regions, stop at a B dump. If you do stop region XXX cancel, you could bring down the IMS control region. Okay. And as a last resort, take an SVC dump, kill IMS with a ZOS command or a Megamon kill or ZOS, but then be ready to IPL because things are probably bad. And then what you do is turn off the traces, switch the olds, copy all the data sets, save the RMF data. So now you're ready for the documentation. Okay, after the problem, what can you do? Number one, I'm using IMS-PA and IMS-PI for my examples. Okay, BMC AMI log analyzer has very similar things. But before that, the motto is AGF. Always Google first. Google knows all about the IMS manuals. If you get an IMS user abend, go into Google and search on IMS and then the abend, and it's going to take you directly to the link in the IMS manual that tells you what that problem is for that abend. Always Google first. What if you get an IMS error message, a DFS message, you don't know what it is? Google it. It will find the IMS manual page that tells you all about that message. What if you've got a problem? And for example, if you say search for abend OC4 in DFS ASK00, Okay, Google knows all about the IMS closed APARs and their symptoms. It can find an APAR for you, or you can search on the APAR number. Okay, I do that. I use Google before I even go to the IBM manuals. Google's better. Okay. Otherwise, RTM, read the manual. The IBM documenters are the best in the world. Okay. Don't be afraid to look up everything. If you have a problem, look there first. And there's a link to it. If you have the IMS DC monitor, okay, like I said, U2R20 is no good. What I have here is the IMS PA, JCL, and control cards that I use, okay, when I run the monitor. And then all the output goes out to the Mon reports data set, and you can look at all the reports there. If you wanted to want to know what to look at in the reports, that's another double presentation. Okay. The program trace that I told you about, okay, you can use DFS ERA 10 to print out the LA3A and the LA3B. That shows get unique to the IO PCB, and it'll show you the PCB, and it'll show you change calls and things like that. If you have the program trace to look at the DL1 calls to databases, I'm sorry, this is one more thing on the program trace. You can use IMSPI also to look at those program trace records, and it formats a lot of the control blocks. Okay, here's the PSB trace. You run DFS ERA 10 with an exit routine of DFS ERA 50, and what it'll print is every single database call in the form of DDLT0 control cards. So you can see every call that program made to a database and what came back in the PCB afterwards, and the data that came back. You can really debug your application program. He'll tell you, oh, I made this call, and you can go back to him and say, oh, no, you didn't. Okay. It's got the call, it's got the SSA, and what came back. Okay. And one of my favorites is if you have a DC monitor, then you run the trace, and what it'll show you, okay, these are the control cards, it'll show you every call that program made in order. Okay. And like, for example, on the third call, I did one get unique. I got a GE status code, but I did like 7 IOs just to satisfy the call. Okay. And this is really important to run. It'll also show you DB2 calls and MQ calls. If you're getting deadlocks, you can use ERA 10 or IMSPA, and there's lots of documentation on deadlocks and IMS locking, which I've put here. For CPU, run APA, run strobe. Okay. If you think it's IMS, save that sample data set. You can do an APA extract, and you can send us strobe reports. If you're using synchronous call out, there are 6701 records, and you can print all those out with IMSPI. Okay, and here's another link to those log records. If you've got a TCP/IP packet trace, you allocate a dump directory, and then you format the trace using this JCL, and you're going to see something that looks like this: the source port, the destination port, okay, where it came from, where it's going, and the flags. The flags are the most important thing. Okay, and what I've listed here are some of those flags and what they mean. Okay, do one of these traces, play with it, get familiar with it. Okay, if you're getting these HWSP 1415 messages, it's not IMS Connect's fault. It means TCP/IP gave us back a bad return code, probably because the client went away. Okay. So TCP/IP packet trace can help here. Okay. You'll get an error code, in this case 1127, which is a timeout. Or if you get a 1121, the client did a reset, and you can Google some of the others. If the ID is del dummy, it means the client opened a socket and never sent in a message. If it starts with HWS, it's from the TM resource adapter. If it starts with GMP, it's from the service provider. Okay. Oh boy, I'm running out of time, aren't I? Okay. Analyzing virtual storage. I showed you how to do that. This, if you use the IMS dump formatter, use the EDA option, and it will show you common storage, and it'll show you private storage. Okay. I'm just going to, you can read these later on. Okay. And then there's IMSPA, and I just show you all the reports that I generate with one execution of IMSPA. Go read all these reports. Finally, when the problem is over, okay, when you open up a case, okay, tell us exactly what happened. List the Trancos, list the PSBs. Tell us what's changed in the environment. Okay, include syslog and job log messages. Okay, we can start looking before you even send in documentation if we have enough information here. Send all documentation first, everything, even text files. And this is a list of things that we always want. We shouldn't have to ask for them. Send files with descriptive names. Okay, I made it with only 3 minutes over. That's not bad. Thank you for sticking around. Okay, we're asking you please to give feedback. First feedback was I went too fast. I apologize, but there's a lot of good information there, and you have the recording and you have a copy of this. And just to show you, in the appendix tells you all about the IMS Connect recorder trace. Okay, any questions?
Yeah, I mean, I thought that was incredibly useful. We going through all of those slides with the foils, with all of that information, and we've got some reviewing to do. I think certainly in our shop we have on some of the values and things that we should be setting from some of those. There's a whole host of information there that we'll have to review with our sysproggers and make sure we've got those set up correctly, because I don't think personally we have in our shop got half of even, but I can see a third of them at least where I'm having to we'll have to review those. So that's really, really useful. When you said we've got a copy of the slides, is that available on the website? Have we got that from the normal website to get that, or is that something?
I uploaded them, right? So you should have them.
Yeah. Yeah.
What do you do with them?
Yeah. So as long as they're uploaded, then people should be able to get a copy of those.
I uploaded them just this morning with absolutely the latest updates.
Excellent. That's really fantastic. Yeah. So much appreciated, and thanks for going through those. Have we got any questions just at the end? Anyone can just verbally ask them now if you just unmute yourself.
If not, anytime in the future, you have my email address. Feel free to email me anytime with questions.
Yeah.
Or comments or suggestions.
Sure. I mean, that honestly, that was really, really helpful and
you.
Very valuable, I think, going forward for us anyway. So much appreciate, Steve. And thanks everybody for sticking with this one. We've had a couple of people joining as well, so that's good. So I'd just like to thank everybody for joining all the GSE virtual Geisha UK conference that we've had over the last 3 days. It's been pretty good. There's been a lot of sessions and a lot of streams as well. So thanks for actively participating in these sessions as well. And again, thank you very much, Steve, for doing your couple of very useful presentations. And everybody have a good rest of your day. And the foils are there to study and to act upon, so that we can help each other out when we have problems. So thank you very much.
Okay.
Thanks, everybody. Have a good rest of your day. Appreciate it.